Hi guys! In this lesson, we are going to talk about variables and expressions. The objective of this lesson to write algebraic expression. Let's see what we will have in this lesson. Our vocabulary is quantity, variable, algebraic expression, and numerical expression. Let's discuss about the vocabulary. Quantity is anything that you can be measured or count. So anything you can count it or measure it, that's a quantity, such as weight of something. This is what we call it, quantity. Variable is a symbol, usually a letter that represent the values of a variable quantity. Let me show you some examples. We can say x is a variable, y is a variable. Any symbol that's a variable, it represents something. Algebraic expression is a mathematical phrase that include one or more variables, such as x plus 1, for example. We can say y plus 2, we can say x plus 2y, and so on, plus 1, for example. So algebraic expressions, it must include variable. This is the most important thing that you must know. Numerical expression is a mathematical phrase involving numbers and operation symbols but no variables. Let me give you example. It's, for example, 2 plus 3 times 6 and so on. We can say plus 1 and so on. But we must not have variables. There is no variables in numerical expressions. Let's move on. So in the first problem, we are going to write algebraic expressions from word phrases and the opposite. I will give you word phrases and then you will write algebraic expression. Let's see the first one. The first one we have 32 more than a number n. Just follow your expression. More than, it represents addition. I will give you some keywords that will help you to analyze the word phrase. So 32, we can say more than, we can exchange it into plus a number n, which is n, this variable. That's algebraic expression that's matched to this word phrase. Now 58 less a number n. So 58 less, which means it's represent minus n. Keep in mind, if you have the word then, it will change the order. Always follow the expression. If you have something like that, always follow the expression from left hand to right hand, unless if you have less than or fewer than. This word, if you have exactly the same as this one, the only thing that you must change, less than, for example, less than a number n, in this case, you are going to change the order. You will write n minus 58. So keep this in your mind. If there is then here, in this space, there is then you have to exchange or change the order of your expression. Other than that, follow your expression. Now, what is an algebraic expression for 18 more than a number n? So 18 plus n. That's it. Miss, can I change the order here because of the word then? Yes, I will tell you. You can change the order here in addition because according to commutative property of addition. So you can change the order. Let's move to more exercises. Before I move to the exercises, here is word to symbols. So for example, all the words that represent addition that you must see in word problems, sum, add, plus, total, increase, more than, combined, all together, in all these words represent addition. Subtraction, subtract from. So subtract from, the one that including a star, these words that will change the order. Other than that, just follow your expression. So subtract from, minus, difference, less. So less, you will keep the same order that you have. But less than, no, you will change the order. You will write the opposite. What you have here, you will write it first, then you will write minus, then what you have here, you will write it. So decrease, reduce, remain, fewer. If you have a fewer, then also will change the order. The concern or the problem always in then. If you have then, you will need to change the order. Multiplication, multiply, product, times, part of, twice, area, finally volume. Division, quotient, divided by, divided into, this will change the order also. Spell it, each, shared, per. This per, sometime it represents multiplication also. So you need to understand the problem so you know where you supposed to use it. Equal parts, average, ratio of. So I think these keywords will help you to analyze the word phrases. Let's move here. You will have here writing expressions with multiplication and division. So 8 times the number n. We can say 8 times, we can put the multiplication sign n. But in an easier way, we can just directly write 8 n. If you see a variable stuck with a number like this without any sign between them, that means the multiplication. So this one and this one exactly same. I usually prefer this way. Why? Because this, it looks like a variable, but it's not variable, it's operation. So you must know the difference between them. The quotient of a number n and 5. Just follow your expression. Quotient represents division. So since quotient represents division, you will directly write n. You can write divided by 5, or you can write n divided by 5. So these are the two ways that you can write this word phrase. Let's move on. Now we have what is algebraic expression for each word phrase in part A and B. 6 times a number, 6n, or just put them like that, or you can write 6 times n. The quotient, look, the quotient is division. The quotient of 18 and a number, follow your expression, 18 over n. Now, do the phrase 6 less a number y and 6 less a number y mean the same thing? No. Why it's not mean the same thing? The first one, it means 6 minus y. The second one, it means you must change the order because of the word then. So it is y minus 6. That's it for this part. It's really easy, and I think you had an idea about it in grade 7. Writing expressions with two operations. Let's see now with the phrases will get more complicated. 3 more than twice a number x, step by step. I'm going to write 3 more than plus twice a number x. So that means 2x, 2 times x, which means 2x. Now 9 less than, here I have to focus because less than, it will change the order. So let me write what I have here first, then I will write minus 9. So the quotient of 6 and a number x, the quotient of 6 and a number x, so I will write it here, 6 over x minus 9. That's what I have to do. Why? Because of then. Then it will change the order. You will write what you have here first, then you will write what you have here. You can write it in another way. You can write 6 divided by x, put parentheses to avoid confusing, minus 9. The product of 4 and the sum of a number x and 7. So the product of 4 and the sum of something, the sum of all this, so you will put what you have here in parentheses. So 4, product between 4 and all what I have here. So you should open parentheses and write the sum of a number x and 7. The product of 4 and the sum of a number x and 7, that's what you're supposed to write. Let me give you more exercises. You have here 8 less than the product of a number x and 4. Again, this will change the order, but I have to write all this together. So it must be x, 4x, because the product represents multiplication. So the product of a number x and 4, so it is 4x, less than minus 8. 8, you will drop it as it is. You will just change the order because of less than. Twice the sum of a number x and 8. So twice, you will put 2. The sum of, usually if you have something like that, the sum of, that means these all together, like this one. So the sum of a number x and 8. So the sum addition, so x plus 8. The quotient of 5 and the sum of 12. The quotient of 5, follow your expression. Quotient is division. So quotient is division. So you have to say 5 and the sum of, so divided by all this story, all what you have here. So the sum of, open parentheses, 12 plus x. You can rewrite in another way, 5 divided by 12 plus x. Please don't forget the parentheses so you can get the right answer. Let's move to the next part. Here we have some exercises we must practice them. So, make sure that you try them. 4 more than p, 4 plus p. You can write the opposite. Why? Because you can change the order in addition. Remember, you can change the order in addition and multiplication, but you cannot change the order in division and subtraction. Keep in mind. So that is p plus 4. They will give the same meaning. Y minus 12. Can I say 12 minus y for this expression? No, that's wrong. Because of you cannot change the order. If you have fewer than, less than, in this case you will write like this. The quotient of n and 8. So quotient represent division. So you have to say n, follow your expression. You get first n, so n divided by 8. Or you can write it as a fraction, n over 8. A number t divided by 82. So t divided by 82. You can write it in another way, t over 82. 6.7 more than the product. So this is more than plus 6.7 more than plus the product of the product multiplication of 5 times n. So 5n. The product of 5 and the product of 5 and c. So that is multiplication. So 15c. The sum of 13 and twice a number h. The sum of 13, that means addition, plus twice a number h. That means 2h. Now we have less than. In this case, we need to change the order. So we are going to write what we have here first, the product of 37 and t. So 37 minus 9.85. That's what we have for all the exercises. Now let's move to the last part. If we change the question in a different way, I mean, if we want to use the words for an expression, let's see what word phrases can you use to represent the algebraic expression 3x. Now the opposite, I'm giving you 3 times x. I can represent it by using many ways. I can say 3 times x. I can say the product of 3 and a number x. So here's 2 expressions. So let me show you what we have. So 3 times a number x, or we can say the product of 3 and a number x. Let me give you more exercises. We have here what word phrases can you use to represent the algebraic expression. So I will give you just a sample. So here we have a plus. So we will remember all the keywords that I gave you before. We can say the sum of a number x and 8.1. We can say also x more than 8.1. You can say 8.1 more than x. So here is just a sample. Now, the second one, we can say the product of, for the first part, the product of 10x. Just follow your expression. The product of 10x more than 9. Or you can say 9 is more than the product of 10x. I'll show you all the answer after I finish. N over 3, which means we can say the quotient of n and the 3. N divided by 3. That's another way. So 5x minus 1. Keep in mind, if you use then, that means you can just start with, you have to start with this one. So I can say the product of 5 and x less, without then, less 1. You have to say 5 times x fewer, or we can not fewer, minus 1. You can, if you want to change the order, you can say 1 less than the product of 5 and x. So there is many ways to represent this part. Here is just a sample that will help you. The sum of number x, a number that I'm supposed to put a number x and 8.1, the sum of 10 times a number x and 9, the quotient of the number n, and 3, 5 times a number x less 1. You can put instead of less, you can put minus. You can here change also the quotient. You can put you can put a number n divided by 3. Now, finally, the last problem, we can describe patterns. Let me show you what do I mean by patterns. So here we have the table below, which is this table, shows how the height above the floor of a house of cards depends on the number of levels. So what we want to do, we want to write algebraic expression for what we have here, for this pattern to represent the height of this shape. So basically, the first floor, which is 24. Now, the second floor is given here, they represented by the height of the card, right? The height of the card times 2 plus 24. So this is the second floor. So the third floor, why? Because of 3.5. That's what they gave us. So in each floor, I must put the height of the table here, what I have here, and the height for each card times the number of level. So, and so on. Now, what is the general form that describes this pattern? Let me look at these. These will help me. So, I'm repeating this in all of them. So, that means this is a 3.5. That is a constant in all of them. Times, this is something that changed, which means the thing that changed, which is this is the variable. This is the number of levels. So, they represented by using n. So, 3.5 times n. Finally, we have 24 in all of them. So, that's a constant in all of them. So, just say plus 24. And you are done. That's the answer. So, the answer is 3.5n plus 24. That's it. So what a rule for the height, that's what I just finished it. Give the rule in words and algebraic expression. So what we have written from the table, 3.5 n plus 24. Now we need to write this one in words. So let's change this one in words. We can say 3.5 times, what is this n? The number of levels plus 24. You can say it in another way. 3.5 times the number of level, or we can say from the beginning. The sum of 3.5 times n plus 24. So these are just two word phrases. Maybe there is more than this way, more than these two ways. You can just write them. So here is what we have. Rule in words. Multiply the number of levels by 3.5 and add 24. I'm going to write what I just say. 3 point, because there is many way, as I said, 3.5 times the number of levels plus plus 24. So that's another way to write the rule in words. Now, if a group of students built another house of cards that 10 levels, each card was 4 inches, right? So each card 10 levels. Each card, sorry, 4 inches. These are 10 levels. And they are saying that, and the height from the floor to the top of the house of cards was 70 inches. So all of this is 70 inches. These are 10 levels. I'm not going to write 10 levels here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So all these levels for 70. That's what they are saying. 10 levels, all of them from the height from the floor to the top of the house of cards is 70. And each one 4. I don't know, maybe there is something down or whatever. How tall would the house of cards be if they built an 11th level? If you add one more level, since you know each card 4, just plus 4 to the 70, and then you will get 11 floor. So that will be 74. That's it. So the answer is just 74. Now, what about if we have another group of students? They built another house of cards, and this house of cards with n levels, you don't know this time how many levels, and each card was 5 inches. So each card was 5 inches, and the height from the floor to the top of house was given by this expression. So 34 plus 5n. Now, how tall would the house of cards be if the group add one more level? So one more level, since you know each card 5 inches, that means just add one level, just add 5 inches. And that's it. You can simplify this one by adding these two numbers, which will be 34 and 5, it will be 39 plus 5n. That's it. It's really easy. Just make sure that you read it many times until you get the idea. So here we have also triangle and polygons. So you know that if you have the polygon of 4 sides, you will have how many triangles? You will have 2. So the number of triangles, you will take one side, the number of sides, then you will minus from them 2. So that's what they gave us here. If you notice that here this 2 is constant in all of them. So just keep this 2 as it is. Now 4, 5, 6, this represents the number of polygons. So just exchange the number that changed by a variable. So n. Drop your minus. That's it. Now we need to write this rule. We already wrote the rule. This is the rule. Now write algebraic expression. So what is algebraic expression of this one? That's the algebraic expression, and this is the rule. We need to write the word phrase. The word phrase, we can say the number of sides of polygon minus 2, or you can say 2 less than number of sides of polygon. You can change this part by a number n. You can say 2 less than a number n. It will be also correct. So that's the end of this lesson. If you have any question, you can ask. And good luck. Bye.